Welcome. Today we are discussing Module 10.1, Model Context Protocol, MCP, Intro, Theory. Here is a quick look at where we are in our curriculum. Hello everyone. Welcome to Module 10.1. I am incredibly excited to guide you through one of the most critical paradigm shifts in AI architecture today, the Model Context Protocol, or MCP. Think about the current state of building AI agents. It is painful. If you want to connect a model to PostgreSQL, GitHub, and Slack, you end up writing custom wrappers for each model provider, creating a messy, fragmented architecture. Today, we are going to understand how MCP simplifies this. It serves as a unified, secure protocol that connects AI hosts like Claude Desktop or your custom IDE extension directly to standard local or remote servers. Let's explore the core topology right now. Think of MCP as the physical USB-C port of the AI ecosystem. Before USB-C, you needed dedicated power cords, display cables, and auxiliary inputs for every single electronic device. It was incredibly wasteful and slow. MCP provides that identical plug-and-play standardization but for LLMs. Once an organization or open-source community builds an MCP-compliant server for a database or API, any platform built with an MCP client can ingest its data instantly. This structural simplicity massively speeds up developer velocity and reduces technical debt. To understand the low-level lifecycle, take a look at this sequence. The system relies entirely on standard, lightweight JSON RPC 2.0 messages flowing asynchronously over transport layers like standard inputs/outputs or server-sent events. During initialization, the client sends protocol capabilities and the server replies in kind. Once initialized, the client can request lists of tools or resources, prompting a direct payload response. This clean protocol design keeps processing decoupled, lightweight, and fast. These three categories are crucial to grasp because they organize how the LLM interacts with external systems. Think of resources as external files or logs the model can read to gain knowledge. Think of prompts as custom dynamic templates that format user intent elegantly. Lastly, tools are executable actions that actually change something in the external world, like updating a record, writing a file, or hitting an API endpoint. This clear division of labor guarantees that you control the security boundaries for what the LLMs can see and what they can actually touch. Let's check out a production-grade Python script implementation using the fast MCP SDK. In this code, we initialize a server named Weather Service and register a standard tool called get_weather using a simple decorator. Notice how the function includes clear type hints and docstrings. The MCP server reads these to construct schemas that tell the LLM exactly what this tool does and what input parameters it expects. I highly encourage you to check the link in the description to download this complete architecture diagram and Python script so you can test it locally. Now, let's see what happens in the terminal when we run this server. Whoops! Looks like we've hit a classic live debugging moment right here. As you can see from the traceback, we've encountered a module not found error for MCP. This is a very common issue when setting up new Python projects or cloning repositories. It simply means that the MCP package, which our server script depends on, isn't installed in our current Python environment. This is actually a perfect teaching opportunity for dependency management. To resolve this, we simply need to run pip install MCP in our terminal. Once that's done, you will see the expected output, the server establishing standard I/O streams, starting to listen, and then seamlessly registering the get_weather tool schema when a host app like Claude Desktop handshakes with it. In the logs, We'll then precisely observe those handshakes and tool lists being sent as clean JSON RPC payloads, proving the predictability and solidity of the protocol. As a principal architect, security is always front of mind. When exposing resources or tools via MCP, remember that you are giving an LLM a direct line of sight to execution environments. You should always sandbox your file read tools to designated working directories so the model cannot read sensitive system logs. Furthermore, avoid hard-coding API keys. Instead, let the host securely inject them at launch. Be mindful of token usage too. Ingesting massive CSV logs as plain resources can easily deplete your model's context window and cost you a fortune in token fees. That brings us to the end of Module 10.1. We have successfully decoded the core theory, analyzed JSON RPC handshakes, and saw how easily we can construct MCP servers in Python. In our next upcoming lecture, we are going to get our hands dirty and put all this theory into real-world practice in Module 10.2, Exposing Vector Databases via MCP, Practical. I will show you exactly how to build a production-grade MCP server that exposes semantic vector searches directly to LLM clients. Thank you for tuning in. Make sure to like and subscribe to stay updated, and I will see you in the next module.